Welcome to the hot filtration experiment. In this experiment, we're going to take a mixture of 3 different solid materials, and using the principles of filtration and recrystallization, we're going to isolate one of those as a product, and then we're going to determine the percent yield for our recovery. First, let's look at the basic setup, being sure to follow each step in the lab manual as we move along. Initially, we're going to heat up some water. We put a mark on the beaker just so it'll be easy to fill it to the right mark. Then what we'll do is we'll put our mixture in the hot water. Some of the materials will dissolve, some of them will not. For the ones that don't dissolve, we're going to need to filter that. And so while the water is boiling or coming to a near boil, we'll go ahead and prepare for that filtration. Once the filter paper is folded into quarters, place it into the funnel and then wet it a little bit so that it seats, so that it sticks well to the funnel. The mixture that we're using is a combination of benzoic acid, copper 2 sulfate, and charcoal. And one of those is going to be our product. We will eventually determine percent yield, and to make that determination, we will need to know how much material we started with. There, that should do it. With water very near the boiling point, we're going to pour just a little bit of it onto the funnel, the filter paper in the funnel, to heat it up. We wouldn't want material to crystallize on a cold filter paper. Our mixture is now stirred into the hot water. Some of the material will be soluble in the hot water, and some of it will not. The material that's not can be filtered off, thus eliminating one of the 3 components in our mixture. The material which passes through the filter paper is referred to as the filtrate, and the material on the filter paper is referred to as the filtrand, or more commonly as the residue. So the black material or residue has now been removed, and what we're left with is a clear blue solution of water and all of the materials that were soluble in warm water. The water is still very warm, and so we need to cool it down. The ideal being there are some components which are soluble in warm water, but they're not soluble in cool water. This experiment works because of our solution that's left, the two solutes, only one of them is soluble in cold water. The other one, although soluble in warm water, is not going to be soluble once it's cooled down. So as we cool it down to about 80 degrees Fahrenheit, we can see that there is white particulate matter. Cooling it down further, we get a lot of the precipitate formed. That is our product that we're looking for. So to get the white particulate matter out of the blue liquid, we need to do a second filtration. The filtration is concluded when all of the material is in, the Erlenmeyer flask has been rinsed, and one final rinse of the recovered material. The white precipitate has now been filtered from the solution. And so our original mixture has now been separated into three relatively pure components. A black residue from the first filtration, a white residue from the second filtration, and a blue filtrate from the second filtration. It is the white material that we're most interested in. That's what we want to determine the percent yield. So what we're going to do is we're going to dry it, and then we're going to weigh it. We're going to weigh it by difference. We're going to get the weight of the watch glass, then we're going to scrape the material that we're interested in onto the watch glass and reweigh it. Then we're going to take the weight of the watch glass from the weight of the watch glass plus the material. Using equation 1 in the experiment, we now know the amount of dried product that we recovered, and we know the amount of the starting material that we used. From that, we can easily calculate the percent recovery. And with that, you have all the information you need to perform your calculation and to complete the post-lab questions. Bye now.